Go ahead, we're listening.
All right, yeah. I'm Craig Bladow. I've been attending since Fort Collins in 2016. This is my first presentation. I've been inspired by Joey last year, standing up and doing a presentation on Sunday. So this is about a software project that I've been working on for a couple of years. And it's called CC41, a touch typist calculator.
Over that way. There you go.
There it is. There's a delay. Okay. So what is CC41? It's a recreation of Hewlett-Packard's HP41CX calculator in desktop PC software. Nothing really new about that. And the goal of CC41 is to run almost any program that will run on a 41CX. But it's a departure. A lot of calculator programs recreate, they take a picture of the calculator, they put it up on the computer screen, and then now you're playing mouse games, hitting the functions and the shift keys and all this stuff. Some of the keys map, number keys usually map well, but many of the other functions aren't mapped at all. And I did what 35 keys on a 41. See, it kind of works out with the QWERTY keyboard. You can almost map that to every alpha key and the number keys. So there's been some ingenious mappings. CC41, you can quickly type functions such as 1 over x, rather than having to memorize which keyboard key the function is mapped to. There was one program I was using, and it was N for inversion, which was kind of neat, but okay, you switch to a different program, you have to remember something else. Programs can now be written in your favorite text editor, and they run really fast on your computer as opposed to the original 41CX. So for a bit of the math, uses the PC's native 64-bit floating point number representation. There's 1,000 data registers, and because there's so much memory on a PC, it ignores the size command. And if you query, it's going to tell you 999.
Memory registers, oh.
There's
that actually commands.
There's what?
The 65,000 memory registers or commands?
Oh, program memory registers, 65,000.
41 type program registers.
Yes. Not exactly a one-to-one correlation to the 41,
okay.
but and then 64 flags. So here's a screen, sample screen. It's in a terminal window or console, and you start CC41, tells you the memory's cleared, and it prints out a stack. And because we have lots of characters on screens these days, it also shows you what's in L, and to the very far right you see a little A, and that would be where the contents of the alpha register are. And then for entry, like here, just a simple line entry here, I entered 4321. A space is considered the enter, as well as the return. And then you come back and then those numbers are on the stack. And then I here and I do 4 pluses. And I hit return, and then that adds up 1, 2, 3, 4, which would be 10, and then one more additional plus adds the 4, which pulled back down from the T register. And the time commands are implemented. So here's the time, here's the date. I was on vacation and Richard said, hey, I need these on the 14th. So I got back from vacation and I'm working on this. So any questions so far?
Do you have extended memory in there, or is it simply just because you got so many data registers?
That's a great question. So because I have a file system, I don't really need extended memory. I use getp to retrieve a program that comes from the file system of the computer. So getp say.
So the hard disk is your extended memory. Sorry.
Yeah, hard disk is an extended memory. Yeah. So
3 terabytes of extended memory.
It's a lot of
it's a lot, yeah. And that is a decision because it's sort of a different architecture. So then okay, how do I map those 41CX things into a PC system.
So do you implement the full extended functions, or what portion of that do you implement?
I don't have the percent, but I'm working on implementing the ones that make sense. Well, so
To you.
to me, well, the you know, like the text editor functions make no sense, right? Because we would want, I don't know, who would want to do that when you can just go and do a text editor in PC? Yeah. Let's see if we can do this. There we go. So the Cat3 command, this is an output of the Cat3 command. So these are all the functions currently implemented. The red ones are additions or extensions. I'll go into those a little bit on other slides. Kind of something interesting, you know, on the 41C, there's a run stop key, and that depends on whether you're not running a program or you're running a program. Well, here it's a little different. So you have to have a separate run command, and then in a program you can put a separate stop command. So that ended up becoming 2 commands, and then there's no off button. So there's an off here. Some people like to use exit. You can do Control D. That's sort of a Unix thing for exiting a console program to get out of it. And I'll go into some of these others on future slides. One cool thing, you can launch it and on the command line automatically load a program, and then that program can load and delete other programs, can clear the program, it can load subroutines, and write data to disk storage. So, and this is how I do the testing of the software. I test it with 41CX programs, and so they load, they test the features, they write the results to disk, then they load other, chain in other programs, and some of those programs are HHC contest entries I've done, and just to try out different things. The view and a view commands print out to the console, so you could run a program if you're calculating something, and you could just print out this stuff to the console and then scroll back through and have a record of that. And then there's trace and SST commands to help debug, and I've got an example of that on another slide. We can get this going. So I had to add something, the path commands, because I'm dealing with, you know, multiple terabytes of extended memory, and paths are longer than the alpha register is a lot. So, so here in this example, here's a fairly challenging path for the alpha register, but it'll hold it. So that puts it in there. The double quotes tell it it's an alpha string. It goes into there. Path command copies that to the internal path. And I think it's a 256 character limit. And then you can query it and see what it is. That's what I put in there, which that's good. And then, well, I actually want a longer path, so I'm going to add HHC contests. I'm going to append it to the path with path plus. And now when I do a query, it shows up like that. So that's how we get to extended memory. Some things I did for testing, just kind of interesting. So I want to do memory testing without using the memory to hold counters and things like this, completely on the stack. And it was really, I could probably do it with a lot of swaps, and roll downs and roll ups and all this stuff. But these just really made it simple. So drop and drop L. And so drop just discards the X register and rolls everything down on top of it. So you see I have a 4, 3, 2, 1, I do a drop, and now I have 4 pull down from T, I have a 3, 2, and it didn't go into L. It just went away. Now, with all the experts here, somebody's going to say, oh, you can do that with this command, but I couldn't figure it out. So, and then there's drop L, which actually drops the stack into L. So X just goes into there, and it pulls the stack down. So.
L is last X.
Last X, yeah. So X goes into X. drop L. Yeah, X ends up going into, where was X? 2 ends up in L.
So save X and then drop is kind of what it is. Save X and L and then
Save
drop.
X to last X,
Yeah.
and then
Yeah,
drop.
we are, yeah.
With duplication though.
So that made, without touching memory, that made some things a little easier. So here's an example of a program. So to load it from the file system, I put the name there in the alpha register, and you can type these all out on one line, right? So count P, get P, and list, and then so loaded the program, and here's the listing, and it's just a really simple program. We'll go on to the next part of that. Skip a slide. So with that simple program loaded, I turn on trace mode and do the run command, and so now every line prints out and I see a stack result. So as we step through the program, the stack updates, and I see the commands, and it runs through there. That's pretty handy, but it really can fill up a console really quick.
I was gonna say,
Right.
how fast is that running, Greg?
You can't read it.
Right.
Right? You basically, it's all done,
Yeah.
or it's crashed, and you've got a million things.
And if you do have it in trace, how far back did your
It's
fallback go?
whatever the buffer in
Trace buffer.
the terminal program you're using.
Yeah.
Okay.
So the digits in the program have 6 decimal places shown. Are you in fix 6 or?
Fix 4?
Default's fix 4.
Over on the
Well,
program
the
listing
program.
on the left. 10.0000.
Oh. Yeah, that's just how it printed. That's just the program that prints the format of that. I don't think it's printing it in the calculator.
What I'm saying, if you're entering the program, you're putting 1 plus or 1.000.
Oh, that's a 1. Yeah, that's a 1 plus.
So the display in the program is not the same as the set display mode
Right.
that you have in the application?
Correct.
Okay.
So naturally, so when you write this is lowercase, it gets printed out lowercase. It doesn't care whether it's, well, the labels care whether the case, but you can use uppercase label, lowercase label. It doesn't care for the commands. You can put 10 and then it becomes a float, and 0. Labels don't have to be, you don't have to have an O1. You can just label 1. You can do those sorts of things. That's a really good question. Anything else?
What's go to CCC? CCC is just a label?
A label up above.
Yeah, it's that label.
It's in the form, sorry.
And the 41C, you have to be aware of what numeric labels are a little more efficient than global, or a lot more efficient than global. These are all the same efficiency. So it stores, when you create it, it stores a pointer to the next. It sort of gets compiled when the program gets loaded, and so all these are already resolved at load time.
So is the enter implied between steps 2 and 3?
Yes.
You can key it in if you want.
You can do that in 41. You just enter and then
Right,
delete
right.
it.
And you can put enter in there if you wanted. So the reference document is volume 2 for the HP41CX. And that's really the place to go for most of these. I did write a manual. And the manual and binaries for Windows, Mac, and Linux are on the flash drives, HHC flash drives. Thanks, Eric. And there's a PDF manual there too that kind of explains a lot of this for the program.
So Craig, you said it's in a terminal window. Are you on Windows? Let's pick
Right.
one. On Windows, do you open up a command session and then run a command line program?
Yeah.
Okay, so okay.
Yeah.
All right.
Yep.
It skipped one from, didn't it?
Yeah, he just went back.
Okay.
Yeah.
Sorry.
So yeah, kind of what you were talking about, Bob. So these are just executables, so you download them or copy them to wherever you want them, and then you just run it from the command line.
DOS 32?
Yeah.
DOS 32. Win32?
Well, it's 64-bit, so I don't know if we're running a Windows
Yeah,
32 machine.
No, but I mean, it's just, you know, this isn't DOS stuff.
No, it's not DOS.
Windows 10.
Linux, Mac, and Windows 10. Interestingly, the smallest binary is on the Mac. So in version 0.41 alpha, yeah,
Are all the jump distances compiled
yeah, they're compiled when it's
as
loaded.
you write it,
Yeah.
or as you save it?
When it's loaded into the program, they're
Okay.
because it loads in the text file and it interprets the text commands. So there's no raw code or anything like that.
But it does indirect jumps also, right?
Yes,
Okay.
then those would be computed at runtime.
When it loads the file, if you have XYZ, ABC as one line, no quotes, does it flag it as a compile error?
It'll be flagged as a invalid command.
Okay.
So
So-
yeah,
Is there only one global program in memory at a time?
no, multiple, just like a 41.
So program 1 can call program 2?
Yep.
They're all in memory at the same time? It's not
Right.
loading it and instantiating it as it occurs?
You can load it. You can dynamically load a program. You can dynamically remove a program. You can load multiple programs in if you want.
Are those some of the extension commands? To load?
41C supports all that.
Can a
Well, but it
program-
only knows of the stuff that's in main RAM unless you do,
But an extended memory, you can load
yeah,
stuff from
okay.
there. So
Can a program delete itself?
I think it can. It might. I mean, I can try it.
Yeah.
I think it can. But
Well, the program will go away, but what happens
the
next?
results are not guaranteed.
Wait,
It's not a deterministic operation.
Is there a little bird that flies across the screen?
So that, I don't know, people running code in terminal windows, I've had a long career as a software developer, so I've done a lot of that. That's not maybe a common thing. People click on icons and launch things, but a little more, I go into a little more detail in the manual if you aren't familiar with doing that. So future directions, complete all relevant 41CX functionality, embed in a custom handheld or desktop calculator. This started out when I wanted a desktop printing 41, and probably in 2017 in Nashville, I talked to Eric a bit about that, and it sort of evolved into this program. Now, and since I started this, DM41X came out, and that should be able to accept alternative firmware. So, and that's be an awesome target for this program.
And then you have the IR LED on it, so you can print to a print.
You could print, yes, and it'll run faster than the 41X because you don't have the emulation layer.
Yeah.
Slightly more numeric precision. You don't have to convert programs to raw code, so you don't need the converter program to load code on this, but you can't plug in ROM images.
And what about printing out programs?
Well, when you run them on your PC, they're written in a text editor, and that usually lets you print the program. So you don't need, this doesn't, as it is, it doesn't need to print.
Right, but I'm saying, would it be in normal 41 format, like you showed it?
You say you look at your source file just by looking at the source file.
You look at your source file, yeah. You have a text file in Notepad, and you don't need line numbers. You can do line numbers, or you don't have to do line numbers. It doesn't care; it'll ignore them. But you just do, go to one.
So if you did put in the line numbers, it wouldn't put them in for you?
No, it does on the listings, but that's inside the calculator program.
Yeah, right.
It'd be nice not to have to do the raw code conversion, that'd be nice.
Now the listing, we say in the listing, can you print the listing?
Well, it's
The
your
source
source
file
code. It's
is
your
a
source
text
code
file.
file.
You're not creating the program in the
Yeah.
calculator.
Right, but what I'm saying is, I wanna give my 41 program to somebody else, and I wanna list out, print the 41 program and give it to him.
Just send them the text
Send in the
file.
file.
Send the file.
You make it a text file, just print the file if you need a hard copy.
Wanna look like a 41 program?
No, it's a text file, it's a Windows file. It's just a text
It's an
file.
ASCII file.
Oh, it's an ASCII.
Go into Word and
What
type
about-
your program up and email it.
How do you use special characters like,
Yeah, Roger just asked that.
how
So
do you use
it,
special characters
that-
like?
that- that was
like
fun.
Sigma or something?
that was fun. So actually, if I'll back up, I'll back up to the Cat3 output. So I've got some. I have some plus, some minus, some reg, because
Oh, okay.
No, my question is,
That's
the
how
alpha characters,
That's
Sigma.
yeah. Well, so
Sigma.
part one is you to make it easy to type. Just type some plus, some minus.
No.
But I know where you're
Alpha
going. I
strings
know where you're
with
going.
Sigma.
So part two is if you have a program that you exported and you have a sigma character in it, or you
Yeah.
have the not equals, or a funny little dot.
Yeah.
So it'll accept all that I know of. It accepts at this point, and will convert them internally.
What do you convert them to? And if you want to enter
if
that,
you list it-
those funny characters,
If you put sigma plus in and you list the program, and you load it and you list the program, it'll print out some plus.
But now, he's not asking
I
about
know.
commands, he's talking about ASCII data, the text data
Yeah.
in
Oh,
alpha.
I want to display that information like Sigma equals something on the output.
If you
of the
run
program.
If you-
one X to A,
Yeah.
which ought to put the man in the screen, in the alpha.
What about the hangman characters?
Yeah, if you do one X to A, that should put the little hangman
goose
guy.
fly
So
back.
pretty much, if you can put it in quotes in your terminal, so the character set that's in your terminal, that's how it will print out.
Oh, so you're just taking the bytes as they are.
So
So there is no Sigma character in that sense.
well,
But
if you can encode it,
other characters.
if you can encode it, I think it will take it.
If you just launch CC41 from scratch, right,
Okay.
your internal node, you type two commands, one X to A. Boom.
Oh,
It'll throw something over an alpha, what does
Right.
it show for that character? What's the character set that those
right.
decimal equivalents will translate into?
It's not guaranteed to be the equivalent
It won't be
of the
the
41. It'll be whatever the ASCII
The native
for
machine
one is, which
one.
is
And if you did
like
A
nothing.
to X, it would just bring back the one, right?
yes.
So
Yep.
it's probably code page 1252 or something.
Sure.
What about synthetic functions?
No synthetic functions.
No flying goose.
You store C
No
will
flying geese.
erase
All
the
that
memory.
would stand up and explain.
Yeah.
Zero scores.
Well, first of all, I didn't know if you were done with the slides.
Oh, okay. Well, is there anything else here? Because this is pretty good.
Well, I was gonna suggest, you've got drop and drop L, which I really like. I'd like to encourage you to consider adding a few of the other RPL-ish stack functions, over or whatever. I mean, just look at it and see which
Oh,
ones
yeah.
make
Oh, there's
sense.
all kinds of things.
Yeah.
All sorts of stuff like
Recall
that
it.
would be really good.
Yeah, I
There's
thought
only
about
4 levels.
Yeah, that would be a place to go once I get to like more 41
Absolutely.
CX and then
Yeah.
start looking at RPL.
Yeah, there's things like recall register arithmetic, that's a nice thing.
Yeah,
Recall functions.
I did think about that when I was doing it. That would be a good place to go too.
No, it doesn't. Sand math projects.
I think that's RF, and it doesn't have to be pointed anywhere. When you hold it, you're capacitively using your body as an antenna. So pointing it anywhere doesn't matter.
Oh, it doesn't matter?
I don't know.
It's supposed to be Bluetooth, it shouldn't matter. but I've seen
Seems to work
people
better if I
all day.
pointed at Eric. Maybe he has a button over there, I don't know. So this is sort of just because I could. So the native storage is 8 bytes, and on a 64 bits, on a 41C it's 56 bits. And so when you do ASTO, you only save 6 characters. So in CC41 you can save 8. And so there's these extended A recall and A stow and A shift that does 8 characters at a time. So for this demo, I put HHC 2021 CC41 Nashville in 3 different memory locations and then recall them, and so you can do that. That's I don't know. It was really easy to implement. Let's try this. It's not working that way.
Very
maybe I skipped that slide earlier. There we go.
So
We're at the end.
so explain the limitation of not being able to install ROM images.
Oh, well, it's because it has a parser in there that takes the text input, the typed text of the program, and it then converts it into its internal commands.
Right.
So there's no raw code
Okay.
in there at all.
Okay.
So it's not
an
it's not an emulator.
Yeah, it's not emulated, it's not, you're not
Right.
using the hex codes for the commands and stuff
Right.
at all.
Would, if I thought about this, I probably wouldn't ask the question, so I'm thinking. If you had another emulator, say you were with V41, you loaded the math ROM, it should be possible, maybe probably, to print the program to
Sure.
a text file, store that on the machine, and then load the thing into CC41.
Yeah.
Very good.
Yep.
As I said, I was thinking through it,
If you have text source.
yeah, and you can generate that way, so that you get
Could you know
ROM programs in that. Very cool.
Which programming language did you make this in?
C.
Was beep in your function list?
Beep. Yes. Beep is there.
Good question.
And then I don't have a live console, but
Is beep
what
implemented?
Beep currently does is it prints beep.
So you don't have to.
You have to make the noise yourself.
Tone 1, tone 2.
The tones are on the to-do list.
Oh,
There was some good discussion on the forum about tones that I found, and I bookmarked that discussion.
Now, when it, just mentioning tones, there are synthetic tones also.
well, it's 15 tones.
Yes, there are.
Well, they're very useful for
Yeah.
Morse code programs, for example.
Oh, yeah.
Any other questions?
In alpha, if you enter a quote, a string, text string, normally I assume it converts it to uppercase, or?
No.
You mix upper and lowercase?
Yes.
So
You
have
can't enter
both.
more characters than you can on a 41C.
Okay.
You deserve credit for being bold enough to try and explain a 41 product to this group.
I know. Unfortunately, that Sylvain's not here.
Yeah, exactly.
You'd have a few more questions.
I would. I hope he tries it out.
Very cool.
Very good.
Good job.
Thank you.